Hey guys, so now we're going to continue going backwards with polynomials of graphs. So before we were given a function and then we graphed it, or we were given some circumstances, just the zeros, and if the function was negative or positive, and we graphed it and made the function. So remember that not only do you have to sketch it, but you do have to write a function. Okay, so now we're going to go backwards. We're actually going to be given a graph and we're going to look at the function itself. Okay, so the first thing we want to do is actually maybe even make our chart still, right? So we have our zeros, our multiplicity, which we'll find out after, and then the touch or cross. Okay, now when it crosses, we have to be specific of what that's going to be. Okay, so the zeros I see here are at -3, -1, and 2. Okay, right? There's 3 of them right there. Okay, now here's a big thing. We've talked about before that if it's an even exponent, it touches. It just touches. So as you can see, where it touches is at the 2. Okay, so since that touches, that means this must be an even, and we're going to go with the lowest even we want. Okay, so the lowest even we know that happens is squared. Now, if you look at these two crosses, these cross at different types of, I don't want to say angles, I guess curves, we should say, or functions, right? If you look, this comes straight down, but this is curved like a what? Well, this one comes straight down like a 1, like to the first, where this one looks like a cubic, which is 3. So what I want you guys to keep in mind is even though -3 and -1 both cross, the lowest cross you can have that's linear like this would be 1, where this cross is cubic. It has that cubic shape. So that means we're going to do 3. Okay. Now, let's also make sure our end behavior matches up too. Remember, end behavior, we look at the degree, so we add all these up, and it's even. Does this look even? Yep, they're both going in the same direction. Okay, so now remember, like we did with the ones that were written down, we have to take our zeros and format those. So I get x plus 3. So we want to do the opposite, right? We kind of want to solve backwards. X plus 1, x minus 2. Remember, what makes that 0? What makes that 0? What makes that 0? Okay, and we already said that at the 3, it's going to be to the first. For the -1, it's going to be to the third. And for the 2, it's going to be squared. Now, make sure if it's a positive or negative, okay? So since they're both going up, that means this function must be positive, okay? If you don't need to make your table, then don't make your table. Totally fine. I'm going to make the table as just a step in between, okay? Just to double check on everything. So now we have our zeros, our multiplicity, and our touch cross. Okay, so let's label our zeros first. So I get -3, -1, and 2. Okay, so let's see, at -3, it's crossing, and it's crossing at like a linear. So that means the multiplicity is 1. At -1 there, it's crossing at a linear, which is also 1. 2, it's touching, so that must be an even, and the lowest even we have. And as you guys can see, totally forgot my other 0 there, right? I have a 0 at 4, and that is also crossing, and it's crossing at that linear, so that's going to be to the first also. Okay. All right, let's make sure our end behavior looks right. So they're going in opposite directions, which means it must be an odd degree. So let's check. 1, 2, 3, 4, 5. Yep, 5 is odd degree. We're good to go. Okay, so let's put this in our binomial. So we get x, remember it's going to be opposite. So plus 3, because what makes that 0? -3. That's going to be to the first. Then we have x plus 1. That's going to be to the first. We have x minus 2, and that's going to be squared. And then we have x minus 4 to the first. Okay. Now, one more thing to check. Is it going to be positive or negative? Well, remember, think of our disco, right? If it's positive, our left side goes down, our right side goes up. But as you can see, this is flipped. And what makes a function flip? The function being negative. Okay, one more. Actually, if you wanted, you can pause the video right now, try it out yourself, see if you get the right answer. Zeros, multiplicity, touch, cross. Okay. So we have -3, -2, and 1. Remember, our zeros are only our x-intercepts, not our y. Okay, so -3, it's crossing, and it's crossing it like a straight through cross, that linear cross, so it's going to be 1. 2 is crossing again, -2, I should say, is crossing again, but it's at that linear, so it's also going to be 1. Sorry, my pencil is falling apart. Okay, and at 1, it's also crossing, but it's crossing at a cubic almost, right? So what we're going to do is use a 3 for that. Okay, now let's make sure they're going in opposite directions, so it must be an odd degree. Let's check. Yep, 5 is an odd number. So let's put in our binomials. That's x plus 3, and that's to the first. X plus 2, that's to the first. X minus 1, and that's to the third. Okay, now let's check our positive and negative. Opposite, it is discoing. Our left is going down, our right is going up, so that means it's a positive function, and we're good to go. So one thing I do want to say too is, no, you do not have to have a 1 there when it's to the first degree. I'm just writing it in just so you guys can see. All right, now let's do some practice.